Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the June 2019 Algebra 2 New York Regents exam. This is going to be a thorough step-by-step consideration of the solutions to the problems. If you would like a faster coverage, feel free to visit our website at mathgotserved.com under New York Regents, and you can gain access to the transcripts of this presentation, and you can go over it at your own pace. Don't forget to subscribe to this channel for updates to the remainder of this review series. Alright, let's take a look at question 1. In question 1, we're going to be assessing the different ways to collect data, either census, experiment, observation studies, or a sample survey. Question 1 reads, a sociologist reviews randomly selected surveillance videos from a public park over a period of several years and records the amount of time people spent on a smartphone. Question, the statistical procedure the sociologist used is called. So what statistical procedure is this? So what we're going to do is we're going to go over these 4 different statistical procedures and see which one best represents what this sociologist used. The first one is a census. Now, what kind of statistical procedure is a census? A census is simply the list of individuals in a population. Alright, so the list of individuals in a population along with their characteristics like their age or gender, for example. Okay, the list of individuals in the population with individual characteristics. For example, if this sociologist wanted to count the number of people in a particular city and then document their race and their age, stuff like that, that will be representative of a census statistical procedure. But in this particular case, this sociologist is looking at randomly selected videos, okay? Randomly selected surveillance videos, so definitely is not going to be all the people in a particular area. And then the sociologist is recording the amount of time. So the sociologist is basically recording what he or she observed from the behavior of the people in the sample group. Alright, so this is definitely not a census. Census just involves counting the number of people in the population and recording the individual characteristics, like physical characteristics of those people. Alright, so option 1 is not the statistical procedure that's being used here. Now let's move on to option 2, an experiment. Well, what kind of statistical procedure is an experiment? Well, an experiment is a situation where a sample group that is being studied is manipulated, okay, or influenced in some way. So an experiment is a situation where a sample group being studied is manipulated or influenced in some way. Okay, so let's say this individual had a select number of people in the park run around the track, and then the sociologist records their heart rate. Okay, that would be an experiment because this sociologist manipulated them by causing them to run. Okay, so that altered their heart rate. So then this sociologist was then able to collect the data. Okay, in this particular situation, the sociologist just recorded the amount of time the individual spent on their cell phones. Was there any interaction between the sociologist and these individuals? The answer is no, because the sociologist is using a surveillance camera, videos from a surveillance camera, so there is no interaction whatsoever between the sociologist and the people being studied. Alright, in order for an experiment to happen, not only is there interaction, but there's also manipulation or they being influenced in one way or the other. So is option 2 what's going on here? The answer is absolutely not. This is not an experiment. How about option 3? An observation study. This, ladies and gentlemen, is definitely what's going on here. Okay, when you have an observation study, the sample population being studied is just measured as they are. Okay, so a sample group being studied are measured as they are. Okay, are measured as they are. So there is no manipulation or questioning whatsoever. For an observation, you just look and record, and that's exactly what's happening here. The sociologist is just looking at the videos and just recording the amount of time people spend on their cell phones. So the statistical procedure that the sociologist used in this particular scenario is an observation study. Okay, so that's the answer. Well, how about a sample survey? What is that? Well, a sample survey involves questioning. Okay, so in a sample survey, a sample group being studied the individuals are questioned or interviewed. Okay, questioned or interviewed. Is that what's going on here in this particular scenario? The answer is no, because you cannot interview someone by watching the video of them, right? You can just only observe. So in this particular situation, we do not have a survey because the sociologist isn't asking these individuals any questions. It's not possible. There has to be some kind of face backwards and forward communication between the sociologist and people in the sample group in order for a sample survey to take place. So we can clearly see that option 4 is not the answer. The correct answer is option number 3, because the sociologist is just observing the group that's been studied exactly as they are. Alright, let's take a look at question 2. In question 2, we're being assessed on how to expand binomials. Okay, we're going to be expanding binomials raised to the second and third power. We're going to be using the distribution of fold method and the Pascal's triangle to expand these binomials, and also the box method too. Alright, so question 2 reads, which statements are true for all real numbers? So let's start with statement 1, expand that and see if it's true or false. Then we will advance to statement 2. Alright, so let's start with statement 1. The question is x minus y quantity square equal to x square plus y square, is it? So what we're going to do is we're going to expand the left side and see if it equals to the right side. Okay, so expand x minus y square. So x minus y square just basically means you're multiplying x minus y by itself. If you know the formula, you can do this real quick. A square minus 2ab plus b square. You apply that here, and you can mentally compute the expansion of this binomial as x square minus 2xy plus y square, which is different from that and is false. So let's act as though we don't know that trick. We're gonna multiply it out. Alrighty, so first, outer, inner, last. That's how you multiply two binomials. When you carry out the multiplication, you are going to get first x times x is x squared, x times negative y is negative xy, negative y times x is negative yx. Multiplication commutes, so you can also write that as negative xy plus y squared. Okay. If you combine the middle terms, you're going to have x squared minus 2xy plus y squared. Ladies and gentlemen, is this equal to x squared plus y squared? The answer is no. This is false. Alrighty, so it cannot be option 1. Now let's take a look at option 2. Option 2 states is x plus 3 raised to the third power, is it equal to x to the third plus 3xy plus y cubed? Is it? Well, let's see. What we're going to do is we're going to go ahead and expand the left side since the right side is already expanded fully. So expand that. Okay. So x plus y to the third is x plus y times x plus y times x plus y. Okay. Raising to the third power means you are multiplying by itself 3 times. Alright, so let's go ahead and carry out the multiplication. We'll do it 2 at a time. Alrighty, we are going to multiply the first 2 first and then multiply the resulting product by the last binomial. Alright, so when we follow that out, first outer inner last, we're going to have x squared plus xy plus xy plus y squared, okay, times x plus y. And then we can combine the middle term here, positive xy and positive xy. When we combine those, we are going to have x squared plus 2xy plus y squared times x plus y. Okay, now we're going to multiply this trinomial with this binomial here. Whenever I'm multiplying with polynomials with 3 or more terms, I like to make use of the box method. The box method helps me stay organized and it reduces the chances of making mistakes. Okay, so let me show you the box method. You don't have to use it. You can just distribute. Alright, whatever method you like. So I'm going to use the box method here. So it's just a multiplication grid. Alrighty, so I have 1, 2, 3 terms there. So just break it down. 1, 2, 3. Oopsie. 1, 2, 3. And then 2 terms here, like that. Okay, so we're gonna put the first factor on the top. So x squared, this x squared column, 2xy. This is 2xy column, and then this is y squared. They all positives, okay? So don't put the sign. And then x plus y, just put an x here, and then positive y down here. Now let's multiply. X times x squared is x to the third. X times 2xy is 2x squared y. X times y squared is xy squared. Y times x squared, we can write that as x squared y. Y times 2xy is 2xy squared. And then y times y squared is y to the third. Alrighty. Now let's go ahead and combine like terms. We have x to the third has nothing to combine with, so we just bring that one down. So the product is going to be x to the third, and then let's see, 2x squared y and x squared y are like terms, so I can combine these two. So x squared y has an invisible coefficient of 1. When I add these two together, I will have what? Positive 3x squared y. Okay. And then xy squared and 2xy squared are like terms. I can combine those together too. So 2xy squared and xy squared are like terms. I can combine them together. This also has a coefficient of 1. So 2xy squared and xy squared can be combined to give you 3. So positive 3xy squared. And then the last term is y to the third, so plus y to the third. And that's your final answer. Okay, we can combine these two because we have x squared y and xy squared. Is this equal to x squared plus 3xy plus y cubed? The answer is no. This, ladies and gentlemen, is false. They are not equal to each other. Alrighty, so neither statement 1 or 2 are correct. Alrighty, now the method that I use right here is I just multiplied out. Okay, multiply out. There's another method which I prefer, which is faster if you know how to use it, to expand binomials of higher powers. Okay, if you have a binomial raised to a third power or higher, you can use the binomial theorem or Pascal's triangle. Alrighty, the one and the same thing. So I'm gonna show you how that works. So we're just going to do this multiplication again. Expand x plus y to the third. But what we're going to use this time is we're going to use Pascal's triangle or the binomial theorem. Okay, binomial theorem. Alright, so let's see how that works. So we're trying to expand x plus y to the third. So we're going to use Pascal's triangle. We're going to the third power, so we're going to generate Pascal's triangle up to the third row. Alright, so starting with row 0 is 1, 1, 1 for row 1, 1, 2, 1 for row 2, 1, 3, 3, 1 for row 3. Okay? Remember, you always start from row 0. So Pascal's triangle is generated by putting 1 at the ends, and then you add the two numbers on the top to generate the bottom middle number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. Bam. Okay, so these represents the coefficients. Okay, part of the coefficients, but in this particular case it actually is a coefficient. So I'll take these numbers right here, the third row of Pascal's triangle, 1, 3, 3, 1. Some of you already have this memorized, and I'm going to line it up. So we have 1, 3, 3, 1, and then I'm going to take these two terms, we're multiplying x and y, so I'm going to have x, 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 x. Alright, so 1 times x, 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 and then times y, times y. This is just a different way to expand binomials, okay? Alright, now I'm going to put in their powers. The x is the first term, so it starts with all the power, and this starts with no power. And then the power of x descends to 0. Okay, so 3, 2, 1, 0. Alright? And then the power of y ascends from 0 to 3. 0, 1, 2, 3. So just multiply these out, add them up, and that will be your final answer. Alright, team? So for the first term and last term, the terms with the 0th power are going to be 1. So y square is y to the 0th power is 1, and x to the 0th power is 1. Okay, so let's multiply them out. Okay, so 1 times x to the third times 1 is x to the third. X to the third. And then 3 times x squared y is 3x squared y. 3 times xy squared is 3xy squared. And then 1 times y to the third is y to the third. If you add them all together, you get x to the third plus 3x squared y plus 3xy squared plus y to the third. And that's exactly what we got here. X to the third plus 3x squared y plus 3xy squared plus y to the third. And we see that it is not equal to x squared plus 3xy plus y to the third. Alright, so this is just a different way of expanding binomials. Whichever method you use, you can clearly see that neither 1 nor 2 are true. Alright, so question for you. Which method do you prefer for expanding x plus y to the third? Do you prefer just multiplying it out, or do you prefer the Pascal's triangle / binomial theorem? Let us know by posting your vote in the comment section below. Okay? Alright, let's take a look at question 3. In question 3, we're going to be assessing how to solve a system of linear and quadratic equations. Question 3 reads, what is the solution set of the following system of equations? So here we have a linear equation and a quadratic equation. Alright, so what we're going to expect to happen is, well, you could have no solution where there's no intersection between the parabola and the line. You could have one solution, maybe a point of tangency. The line is tangent to the parabola, or you can have two solutions where the line basically cuts through the parabola. Alright? Okay, so let's go ahead and solve this. This can be solved with a graphing calculator, or you can solve this algebraically. We're going to solve this algebraically, okay? So we have y equals 3x plus 6 and y equals quantity x plus 4 square minus 10. Alright, so let's label our equations. Let's call the first one equation 1 and call this equation 2. Okay, trying to stay organized here. Now what we're going to do is we are going to use the substitution method to solve this quadratic equation. What we're going to do is we're going to substitute 3x plus 6, the y value from equation 1, into equation 2. So let's write down what we're about to do. We're going to substitute 3x plus 6 for y in equation 2. Okay, remember 3x plus 6 came from 1, that is why we are plugging it in 2. If we carry out that substitution, basically what we're doing is taking this right here, and we are plugging it in here. If we carry out that substitution, we are going to have 3x plus 6 equals the quantity x plus 4 square minus 10. Now this is a solvable quadratic because we have one equation with one unknown. Let's expand the right side first, get rid of that unknown parenthesis. So we have 3x plus 6 equals x plus 4 times itself. You can use the shortcuts we talked about in question 2 to do this, but let's just do it the long way. So we'll follow that out. We have 3x plus 6 equals first x squared, outer 4x, inner 4x, last 16 minus 10. Now let's go ahead and simplify. We're going to have 3x plus 6 equals x squared plus 8x. Combining the middle terms, your like terms. Okay, so I'm combining the first degree terms. 4x plus 4x is 8x. Alright, plus 16 minus 10 will yield positive 6. So now what we're going to do to solve this quadratic is we're going to put it in standard form. Set it equal to 0 and use the zero product property. To do that, we'll simply subtract 3x and 6 from both sides of the equation so that it is equal to 0. Alright, so subtract 3x and subtract 6. Okay, so I'm going to develop my workspace and continue working on the right side here. So when I carry out that subtraction, I'm going to end up with what? What am I going to end up with? I'm going to end up with 0 equals x squared plus 5x, and then plus 6 minus 6 is 0. Alright, so how do we factor the right side? Well, let's switch it around first. Okay, so x squared plus 5x equals 0. Now I can factor out x. Okay, so I factor out x, and we have x plus 5. So I factored out x from both terms because that was a like term. Now we're going to use the zero product property, so x equals 0 or x plus 5 equals 0. This is already solved. To solve the one on the right, all you do is you subtract 5 from both sides, and you end up with x equals negative 5. Okay, so there are the two x values for our solutions. We can automatically eliminate 1 and 2. Oh, we can also eliminate 3 too, because x, wait a minute, hold on. Yeah, x is negative 5 and x is 0. So we can eliminate 4 because the only option where x is 0 and negative 5 is option 3. Okay. Now, what if this were not a multiple choice question? What if it was a free response question and you were asked to find the coordinates of the solution? Okay, express the solutions as points. What are the coordinates of the points of intersection? So if you notice that in option 3, you have x and y and the 2 points, right? How do we get the y component? In order to get the y component, all you simply do is evaluate any of these two functions, either the linear or the quadratic, at the specified input values that we got as our solutions. Okay, so which one do you think is easier to evaluate, the quadratic or the linear? It's just the linear, right? Because the linear you multiply by 3 and add 6, that's it. But for the quadratic, you have to add 4, you have to square, and then subtract 10. Too many operations. So we're going to use the easier one. Use y equals 3x plus 6 to find our desired output values. So for the first point, all you do is you look for y at 0. Okay, so using x equals 0. So y at 0 means you're just going to plug in 0 for x. So 3 times 0 plus 6. PEMDAS this real quick. 0 plus 6 is equal to 6. So that tells us that the first point of intersection is what is it? Let's write it as a parenthesis here. The first point of intersection is 0 for the x, 6 for the y. Bam. Alright, so that's how you do it. And then for the second point, you evaluate the linear function at -5. So it's going to be 3 times -5 plus 6. Multiply this out, you have -15 plus 6. Alright, still using PEMDAS. -15 plus 6 is -9. So the second point of intersection is -5, -9. Alright, so we can clearly see that the answer to question number 3 is option number 3. Alright, let's take a look at question 4. Question 4 is assessing our ability to see the relationship between time, speed, and slope. The scenario is as follows. Irma initially ran 1 mile in over 10 minutes. She then began a training program to reduce her 1 mile time. She recorded her 1 mile time once a week for 12 consecutive weeks as modeled on the graph below. So we have the graph there. Question, which statement regarding Irma's 1 mile training program is correct? Alright, let's take a look at the first one. The first one says, her 1 mile speed increased as the number of weeks increased. Alright, so if we take a look at this option, option 1 is basically stating the relationship between speed and the number of weeks. Okay? Now if you take a look at this graph, the graph is going down. As the number of weeks increases, the 1 mile time decreases. Alright? This graph is showing the relationship between time, 1 mile time, and number of weeks. But question 1 is asking the relationship between 1 mile speed and number of weeks. So what's the relationship? How can we connect time to speed? Alright, so in order to do that, there's something we want to note concerning the relationship between time and speed when the distance is constant. Alright, so what you want to note is as follows, is that the speed varies inversely with the time with a fixed distance. So what does that mean? It means that if you're traveling faster, it will take you less time. Okay? If you're traveling slower, it will take you more time. So that's what inverse relationship means. So case 1, if the time increases, the time to cover a distance increases, that basically tells you that the speed is doing, you're traveling slower, the speed decreases. Alright, and the reverse, for a fixed distance, if the time decreases, then that means you must be traveling faster. That's why you are able to cover that same distance in a shorter period of time. Okay, so just think about inverse means when one goes down, the other goes up. So time decrease, speed increase. Okay, and then when time increase, speed decreases. So you see the connection here. So in this graph, this time is decreasing. So if the time is decreasing, the 1 mile time is decreasing, guess what's happening with the speed? The speed is increasing. Okay, so here it says the 1 mile speed is increasing as the number of weeks increase. Well, this is true because speed is inversely related to time. So the time is decreasing on this graph. That automatically tells you that the speed is increasing also. Statement number 1 is correct. Alright, so that's the correct answer. Alrighty, let's take a look at question number 5. Question 5 is assessing our ability to find the sum of a geometric sequence, also known as a geometric series. Question 5 reads, a 7-year lease for office space states that the annual rent is $85,000 for the first year and will increase by 6% each additional year of the lease. What will the total rent expense be for the entire 7-year lease? Okay, so what kind of terms are being generated in this lease that we're looking at right here? It's increasing by 6%, by a factor of 6% each year. So is that going to be arithmetic or geometric? So let's note the following point. Growth by a rate of, notice rate of 6% each year means that you multiply by a growth rate of 1 plus 0.06, okay, which is equal to 1.06. So a growth rate by 6% means that you grow by 1 plus the rate in decimal form. Growth rate of, this word of right here indicates multiplication. Okay, it indicates multiplication. So whenever you're multiplying by, whenever you have rate of a particular percentage, you multiply by that percentage. Either if it's a growth or decay, you subtract or add from 1 and then you multiply. Alright, so we're going to be multiplying by 1 plus 1.06 every single time because the rate, the percentage was 6%, which is equal to 0.06 in decimal form. So since it's growth, you're going to be multiplying by 1 plus the growth rate. If it were decay, it would be a subtraction. Alright, so we're going to be multiplying by 1 plus 1.06 over and over again. So in year 1, it was 85,000. Okay, just to illustrate, in year 2 is going to be 85,000 multiplied by the factor 1.06. In year 3 is going to be 85,000 multiplied by 1.06 multiplied by 1.06 again. So you keep multiplying by 1.06 over and over again. So whenever you keep multiplying by a constant value known as your common ratio, that, ladies and gentlemen, is a geometric sequence. Alright, so we're going to be adding terms of a geometric sequence. When you're adding terms of a geometric sequence, the formula that you're going to use is the formula for the sum of a finite geometric series. Alrighty, so let's write down the formula. Formula for the sum of a finite geometric series The formula is given by the sum of n terms of a geometric sequence is a1 times 1 minus the common ratio raised to the nth power divided by 1 minus the common ratio. Okay? Alright, so let's go ahead and apply this formula to this particular scenario, but you need to know what each of these values mean. Okay, so a1 is basically the first term, r is the common ratio. It's not the growth rate, okay, you gotta be careful. The common ratio is basically what you multiply over and over again. So in this case, you notice we kept multiplying by 1.06. That's the common ratio. And then in this particular, n is the number of terms. Number of terms. In this problem, we're looking at 7-year lease, so our n is going to be 7. Now let's specify what we know and what we need, plug it into the formula, and calculate what the sum of the amounts for the first 7-year lease will be. Alright, so A1 was the first term. Starting amount is 85,000. The growth rate is 1.06. The number of terms is 7. So S sub 7 is what we're looking for. Using that formula, it's A1 85,000 times 1 minus the common ratio 1.06 raised to the 7th power divided by 1 minus the common ratio 1.06. Alrighty, so just plug this into our calculators and that will tell us what the answer is. We're going to be using the TI-83 Plus for this computation, so we are going to have 80, let's do it this way so we don't mess it up, parentheses 85,000 parentheses 1 minus 1.06. You use the caret button. Where are you, caret button? Right here. Bam. Raised to the 7 to exponentiate. Alright, so you notice I have two parentheses. The first parenthesis closes this 1 minus 1.06 to the 7. The second parenthesis closes the numerator divided by the denominator. I didn't put a parenthesis here. Divided by the denominator. The denominator is 1 minus 1.06. Close that. Hit enter, and then you get 713,476.20. Alright, so the amount is going to be 713,476.20 cents. That, ladies and gentlemen, is the final answer. So the answer to question number 5 is option number 4. That is how you use the sum of finite geometric series formula to find the sum of n terms of a geometric sequence. Thanks so much for taking the time to watch this presentation. Really appreciate it. We'd like to know what you think about this review tutorial. If you found it helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to the remainder of this review series. More complete support resources can be found at mathgotserved.com under New York Regents. Thanks again for watching and have a wonderful day. Goodbye.